Uh, Good afternoon. Basically, Washak gave something about Fourier to Katian, and I don't think I can quote any of the bigwigs, but at least the boss of Danzig and the boss of our research are identical. We are also funded by the Defense Department, so hopefully we'll do something good. The title of my talk is Data on Air Towards Wireless Internet. I'll give you an overview of what we are doing with respect to providing internet services to moving users. And the wireless part is sort of taken for granted unless you have a very long wire and you don't mind moving with it. Typically, if you move, you better be wireless. The Dataman project is, at least from the computer science department, two of us, Thomas, who is the chair of the department as well, and myself, and we are in close collaboration with WinLab, David Goodman, Dick Frankiel, and Jim Evans. I'll give you an overview of the 4 sub-projects that we are working on, and all of it sort of falls under the rubric of providing information services to moving users over a wireless link. The first work that we are doing is basically what kind of network should we build and what kind of a quality of service. It's a big word, but basically what kind of performance should the network provide when users, not only you have millions of users, which is the case of the internet today, but also these users are moving all around the place. That's number one. And the second one is a new project which we call Infostation, which was first proposed by Dick and Thomas. The idea is that we don't need wideband or lots of bandwidth everywhere, but maybe at some very strategic locations, like a entrance to a building, at a traffic light, or at the exit ramp. So when you drive by, you should be able to download information because there's a lot of bandwidth only at that location. So it's like if you need cash, you go to an ATM machine. So if you need information, you go to the info station. And the third project is basically on geographic messaging or geo routing. Some of you must have seen the demo that Julio was showing. Here the idea is, today we know how to deliver messages to a specific address or a specific machine. But what if we needed the capability to deliver messages to a geographic area? For example, how do you say that send a message about traffic to everybody on the turnpike? So only people on the turnpike should get this message, and anybody else outside should not get this message. And finally, this is a new word. Basically, if everybody is moving around and they want information services, what they're interested in, what's around them. How do you provide this information as you move is a very interesting problem, and that is a new term that's been coined as field computing, geographic information services and mobile computing. So I'll go over each one of those in a little bit of detail. So we are being funded by DARPA and NSF and also all the sponsors of WinLab. So if you want to take something out of this talk, this slide should be enough. In the sense, what are we doing? What's the research component of our work? So we are trying to provide information services to moving users. And under this umbrella, we are looking at how to provide integrated services in mobile networks. That is, either you have a voice network like the cellular phone of today, or you have a totally data network like pagers or the internet. The idea is, how do you marry both of them so that not only you provide data services, but also voice services in the same network to moving users. I mean, you must have already heard in the Popular Plus about the internet phone and all that, so that's there. But still people are grappling, how do you provide an integrated service wireless network when you have moving users? And the second problem is that as the information becomes rich, suppose you want to download a 30-page fax, you need a lot of bandwidth. And you can't provide gigabits per second all over the world. There may be some places where nobody's going to use. So the idea is, why not do at a certain well-known locations where you know that a lot of people are going to go by. And that project is basically the Infostation project. And finally, the field computing aspect of this work is, we want to provide information services, assume that we have a network, and also people are moving. So when people move, they always want local information. That is, if I have access, if I have some handheld device and I'm connected to the network, if I want weather, 90% of the time I need weather in New Brunswick. Yeah, 10% of the time I may be going to Paris, I want to know. But reasonably you would like to know what's around you, what's local. So how do you provide local and personal information? How do you broadcast this information? How do you scope these messages geographically? These are some of the issues that we are looking at in the third. So the first is, how do you provide integrated services when people are walking or driving? If you look at a lot of research that we initially did also, we expected that people would require a lot of data services to begin with. But it's very unlikely that you would be clicking and browsing CNN.com while you're walking or driving. Of course, you're in the passenger seat, you can do that. But driving, it's not a good modality. So voice seems to be very natural for people to both not only input their commands, but also get a response from an information service provider when you're moving. So why not make voice as a first-class object in a mobile network? And the rest of the data services, which are not necessarily real-time, like email, file transfers, and so on, can be provided as a lower priority service. So what you have here is, for lack of a better word, the internet backbone. And we want to bring IP packets to moving users. Okay? So the idea is, a good example is the internet cellular phone. So how do you provide these services? And what are the challenges also in providing these services? First of all, well, the internet cellular phone is a good example of a service, but the research underpinnings are much broader than just this particular service. The first is, why are we looking at this internet cellular phone as opposed to internet phone that everybody already knows about? First of all, we as network protocol designers don't even know what kind of support we need in order to provide an integrated service to moving users. What kind of service classes we need to provide. And also, what's the advantage of integrated services? That is, once you integrate, you can service multiple applications using the same network. For example, you may be talking while you're walking or and talking and driving. In the background, somebody may have sent you a message which you can browse at your own pace. And also, many of you may not have noticed, most of the companies are using www.xxx.com as a major source of entry point into customer product information, customer service, and so on. But that's fine. People may be able to browse product information, as a keynote speaker also mentioned about Dell and Egghead software and so on. The idea is here is, yes, that's data, but what if there is a small 800 number somewhere there, and you also like to talk to some human being or some other person for additional information? You don't want to use another network like the phone network. So it will be nice if not only you look for data, but if at all you want to make a voice interactive conversation, you should be able to do it in the same network when people are moving. And that's the challenge here. And also, how to provide some value-added services. What does it mean to provide in an internet kind of network when people are moving? How do you provide something like a cellular teleconference? How can you provide a video conference? People have worked in multicast, but we still don't know how to do mobile multicast. That is, when users are moving around. It's still an open problem. We did some initial work. There are some other people working, but we still don't have the solution which some standard will eventually deploy. Those I see a lot of students as well. So conceptually, what's the problem? What's the big deal when people move? What's so hard about providing support for real-time services when people move? I'll give you a very simple example here. Typically, let's assume there's a source. Don't worry about this word home agent. This is a terminology that the mobile community is using it. And some of the packet travels to your car or your internet cell phone. Now, when you move, the path or the route path over which the packets go will change. So the end-to-end delay that the network thought it had or it could give is no longer valid. And worst case, for all you know, this path may be congested. So you may not be able to support the same kind of TCP traffic that you thought you could in the previous place. So how does the network compensate for variations in things like various metrics like bandwidth, delay, when people move over a network? Okay, and that's what we are looking at. So a lot of people think internet should only do best effort and nothing else, but that's not going to work. There's already the debate is already won in the sense at least there will be some service differentiation, there will be some priority of services, people will do service differentiation. It will not be just best effort, especially when people start paying for these services. If you pay for it, then you'll definitely ask for some quality of service. So if you're moving, what's new is that network should be able to give you a guarantee which has some spatial component. That is, a moving user will always place some spatial demands on resources on the network. So he may ask bandwidth here, bandwidth there, bandwidth elsewhere. So the question is, when I ask for a service and I tell the network, hey, I'm going to be in New Jersey today, or I'm going to be on Bush campus, can you provide me this service? Can you provide me this quality? Maybe the network can come back and say, yes, I can, or I cannot. Okay? How do you do that service? So in terms of research, this is what we are doing. We are working on a new architecture for providing integrated services in a mobile network which is IP-based. Obviously, we are coming up with new service classes because the service classes that are defined today are not valid for moving users. They're only good which can take care of variations in a flow from one point to another point. It doesn't have the spatial component. And there's another word that people use, is basically how to make resource reservations in a network when people move and place spatial demands on a network. So we're working on equivalent of what people in the internet are working on, RSVP or MRSVP. And as a result of which, a particular example or an application of what we are doing is the concept of internet cellular phone, where we bring IP to the endpoint with wireless connectivity. And also where we see all this work going is the, I guess this keynote speaker at 3, telecom, communication, data. Here at least we are looking at what happens when communication services and data services converge. How do you provide some services like this? Call me if it's for my boss. Where do you keep this information? How does routing decision base take care of constraints imposed by the user? These are some interesting challenges. The second aspect which I'm going to say about the Infostation work is, we are not going to say that we will provide gigabit per second all over the world. Maybe in the backbone, but definitely not at the fingers or the edges of the network. So ubiquitous broadband may be an oxymoron. All right? So wireless extension to gigabit Ethernet maybe, but still it may not be cost effective to provide wideband coverage all over the world. So what's the alternate? So the alternate is basically the concept of Infostation. This is just a new project which is funded by DARPA. Initially, Thomas and Dick Frankiel wrote a paper on this many-time, anywhere communication concept. And the idea here is that we'll provide high bandwidth connectivity at some strategic locations, at an exit ramp, at some well-known locations, or where we know that people will go. All right? So now, the idea is that if you do that, then people will drive by these locations where they know they're going to get high bandwidth, and probably they can download their 30-page fax or a very high multimedia presentation in less than 2 seconds. Or some, since I know PowerPoint and animation, let me show it as well. The drive-by voicemail is a good example. You don't want to download your voicemail over a low bandwidth link. Your voicemail is sitting somewhere in the network. You just download and then listen to it at your own pace. Okay? That's the concept of the Infostation. So the question is, where do you place this? How are the users aware of it? And will users change their route plan so that they could go to the Infostation to download that, right? That means you should be so hungry for information that without it you wouldn't survive, then you would go. Because your car is running out of gas, you normally change your route plan to go to a gas station. So the idea, I don't know, it was David or somebody mentioned that. So while you're filling your gas tank, you can also fill your info tank. I mean, that's the idea. So users will drive by these locations and download large amount of data. And conceptually, this is quite different, because the network people have always looked at, the user says at one attachment point, and the network will fight to provide quality of service by making reservations, trying to do some scheduling decisions and so on. Here we are saying users will go to locations where the network knows the quality of service can be provided. This is quite a radical model from a network perspective. You can also do uploads. You don't have to do download only. For example, you can place an Infostation at the jetway. So you're disconnected, you're flying from here to California, which I'm doing in about 2 hours. And probably I must send 6 or 7 email messages. And especially if you fly into San Francisco airport, it's amazing how many people carry laptops. Maybe it's very computer savvy, I guess. And they all look for a public phone where they can just dump whatever they have done. So instead of that, you just walk out of the airplane, and the Infostation will suck out all the updates in your outbox. And that's an interesting application as well. It doesn't have to be download all the time. Okay. And the architecture itself is interesting. How does the user know where the Infostation is? Maybe in the future there will be some advertisement, just like you know where ATM machines are. That's when what we call an isolated Infostations model. Or most interestingly is that the user has access to an ubiquitous low bandwidth network, like maybe he has a pager or maybe he has a cell phone, and the network will use the low bandwidth network just to tell you, hey, I have this presentation waiting for you at the next info station. For example, the keynote speaker may have wanted the latest information from whatever internet data services about how many billions is the market. His secretary might have said, well, I have updated this PowerPoint slide, which you don't have. He may get a message from the pager, and while he's coming into Rutgers, he'll drive by the info station and pick up those slides. So that could be the low bandwidth ubiquitous network can be used as some kind of information, informing or event driven way, and then info station will be the high bandwidth stuff. And of course, our vision is that probably you would have a network of info stations. That is, what happens if you can't download enough data in one info station? Either you make a U-turn and come back, or probably there is something ahead on the way where you have atomicity of the transfer across a network of info stations. That's much more harder problem. All right, so our research, we are looking at the architecture because there's a radio component. We are looking at how to design these media access layer protocols where somebody is going to drive at 50 miles or 60 miles an hour, and with a meal cell stay time of maybe 5 to 10 seconds, and you want to download megabits of data. That's number one. And also caching strategy. Remember, it's not just the bandwidth that's the problem. You also want to make sure that the data is there and can be delivered before the user leaves the info station. So the question is, where do you cache data so that the time taken to deliver the data is equivalent or under the delay budget that the user can afford? Because if the user is already there at the info station and the data has not arrived yet, it doesn't matter how much bandwidth you have. It's going to take time. So that's an interesting place. And also, we don't know what the modality of the user is. Maybe he wants everything to be read. So where do you do the transformation? Where do you do the cache? It's kind of interesting. And we're looking at, of course, all the protocol design of how do you route something which was normally would have gone by the network that is connected to as opposed to the info station. All right. And the second aspect is, what's new about information services in mobile computing? Whenever you're moving and you have limited resources and you're paying a lot for bandwidth, we believe that the information will be sort of punctuated by personal information and also the local information. So the idea is we need to structure our services such a way that if a user X asks some information, it should appear in one form. If a user Y asks, it should appear in another form. Similarly, if user X asks something in New York, it should have a different content. If the same user asks something in New Jersey, it should have a different content. So the question is not only who is requesting it, but also where it is being requested from. So that means we have to look now at location as a first class object. We need to integrate location information somehow, either GPS, cell identifier, or maybe the user specifies where he is in some approximate way. And we need to know how to route messages geographically. We need to know how to gather information about location. So basically, conceptually, what are we asking as users move is an answer to the query, what's around me? How do you provide this answer? There's some interesting issues there. So an example of integrating personal and local information, suppose you want to download Wall Street Journal from our info station. If you drive by a San Francisco info station, it should look different than a New York info station. Similarly, if I drive by, maybe I'm interested in IBM stock, only IBM stock information will come. Greg may be interested in Sun stock, so he may only get information about Sun. So that's another interesting aspect. So the idea is that somehow we should be able to scope messages geographically, understand location. As sort of prelude to that, what we have done, Tomasz and his student, many of you must have seen the demo of the Geo Routing, is the idea of how do you route messages geographically. We all know how to route messages to specific quote-unquote IP points or IP endpoints, but we don't know how to do it geographically. Suppose you have an interface in the future which says, now that California is inundated by El Nino, you want to send a flooding advisory to people in the Bay Area. So how do you do that independent of who is receiving it? See, remember, in geo messages, we are not interested in targeting a particular person, but we are interested in targeting a set of people in a given geographic area. So how do you filter geographically? That's the work we are doing on geo routing. This is some details. And finally, the merger of these two is what we call as the field computing. That is, we know that most of these information services will have to be somehow indexed based on personal and location information. And the fact is that users are going to move around with different modalities, different access mechanisms, maybe low bandwidth cellular, maybe high bandwidth info stations, and so on. And the question is, how do you provide information? And the word field computing comes from people in the field. For example, I'm outside at a particular location. I'm a soil scientist. I would like to know what the soil composition is. Someone else is interested in the pollution aspects of it. He wants to know what's the pollution readings today in that area. So the question is not only where you are, but also what you want. And that's exactly what we would like to provide in field computing. Things like all restaurants within 5 miles. How does the network respond? And more interestingly, suppose in the future you have a laundromat and you want to send an electronic coupon, the fact that you have $1 off today, to everybody within 5 miles. So everybody driving within 5 miles of the laundromat would see an electronic coupon. And then an interesting concept about this distance-based bookmarks. So you're interested in VCR repair. As you drive around, it always links to the closest VCR repairman. Or you're interested in the shopping mall, you're always linked to the closest shopping mall, the closest golf course, the closest freeway, and so on. Okay. So basically what are we doing as part of this geo routing and geo messaging? We are building a Geobone network, a network which can send messages and understand geographical queries. And Julio is probably trying his best to make sure that we have a geo network at least between New Jersey and some site in California and a military site here in the East Coast. So somebody sitting here could geographically specify where this message should go. And I think it's Santa Cruz, am I correct? Yeah. So somebody in the beach in Santa Cruz will get a message if it happens to be in the right geographic location. And also the routing mechanism is slightly different here. We just don't have to look at the IP address, but also we have to look at polygon containment, because we want to make sure whether this point can be reached by this particular router. And also, how do you broadcast information to moving users? And not everyone, suppose there are 1 million people all asking for the same information, there's no point in making specific requests to the server. You can broadcast. But the problem is broadcasting works if everybody asks the same information. Maybe they all ask the same, but there may be some minor variations with respect to what they want. So how do you couple broadcast and specific way of delivering information? And we have done some work earlier also on this whole notion of how do you broadcast information, how does the user know when a given broadcast is going to come, and this concept is basically the meta-channel concept. And those of you who want to look at our papers and our work, feel free to browse our webpage, Dataman webpage. So let me go back to all right, so yes, I have about 5 minutes more, so let me take some questions if you have. Any questions? Yeah. What is the problem in terms of routing? Oh, no, not for geo-routing. Geo-routing, nothing to do with GIS. In geo-routing, the problem here is, first of all, how do you define geographic reachability? Suppose there are multiple paths from a router from here to the rest of the world. Now, this message is meant for California, right? So how do I know that the second path will lead eventually to the router which can deliver these messages in California? Remember, I need to have geographic containment. That is, as long as I know that this path will lead to entire of California, that's fine. Somewhere along the California, the guy will say, well, I can do Los Angeles, I can do San Francisco, I can do North California. Again, the same concept there. And finally, when you go to the last mile, I will exactly know the geographic polygon over which I can reach, quote unquote, electronically. That's one problem. And yeah, did I answer your question? Yes. Yeah, see, for example, suppose you want to, you know that there are some, let me look at this traffic example, right? Suppose you want to send some information about the traffic jam or something related to the traffic only to a piece of the highway. See, right now you will get traffic message no matter where you are, as long as you can hear the broadcast. But here what we're interested in is, even if you can hear the broadcast, if you're not in the right location, you will not get it. We would like to differentiate or try to put a filter based on where you are rather than what the information is. And so you need the geographic routing capability as well as the notion to understand, well, for these people in this segment, what is the relevant traffic information? Sorry. Oh, I'll go. Okay, go ahead. Let me give Julio an opportunity to answer. In fact, he is actually building what we call a Geobone, trying to collaborate with UC Santa Cruz and Berkeley, so that at least we have a tunnel set up between Rutgers and somebody who is geographically aware at Berkeley and Santa Cruz. Why don't you add some words, Julio? And also, Saul, you asked about the public internet being too crowded and the measurements going to be affected. Correct, yeah. So DARPA has something called, there is a project called KN project where we haven't yet gotten an account. But these are experimental networks among several sites in the United States where you can basically make a total reservation for the network. You can say to this CAIRN, C-A-I-R-N, I don't really know the exact expansion, but somebody has come up with a high-speed multicast mechanism. You want to test it without bothering the internet. You can basically go on this network, and just like any scheduling a room, you can schedule this network for yourself, let's say Saturday from 8 to 10, and nobody else will be allowed to send any packets. And all packets will be sent by your router, by your software on all these places that you're running. So there is a facility like that if you're really worried about how the performance of our mechanism is going to be impacted by existing traffic that's going through there. And definitely, but we haven't gone that way because we were always for implementing and deploying and testing rather than first simulating. You had something there?
Go for this big national Geobone, you can actually think about implementing it here. For example, you could deliver a message to a part of the campus. For example, horizontal between these two buildings, or parts around the class or whatever. You can actually route the message there. And that's the next stage of actually this is just something that the next implementation of the software. And they're actually talking to this people about providing this as a service. It would be a wonderful advertisement also for your for example, that you can go and actually send this message physically to those locations. It will cost a lot for doing it.
Yes, sorry, I'll come back.
Localization, I don't understand what you mean by the localization of message data. When I'm, say, in the parking lot, are you going to send a wireless message to the parking lot?
A wireless would aid in it, but conceptually it's not needed. Maybe you have a ether. Suppose on the parking lot street light pole, you have Ethernet jack. You just connect there. I mean, wireless makes things easier when you. Correct. I mean, otherwise you have to have wireless. I mean, somehow I need to reach you. Uh-huh. That's a good. That's exactly. Correct. No. That's exactly the geo routing. What it does is ability to filter messages, even though you are getting it electronically. So the idea is that suppose you had a GPS information. Suppose you know precisely where you were, you could filter out messages that were not meant for you geographically, right? Just like you don't get a message addressed to me, not meant for you. Filtering. Same idea. Correct. Sorry.
Okay, suppose you have an info station and someone drives along, and I assume that what happens is that when they get close enough to the info station, some sort of transponding goes on, let both sides know
register.
They're there. Okay. Seems to me you have a trade-off between quality of service requirement, because they're only going to be there so long, and if their information is not at that node, it's got to get there fast enough to get down to them while they're exposed.
Correct.
There's a trade-off between that and replicating the data so that it's likely to be where they're going to be, but that in turn would mean that you'd have to try to predict where they're going.
Correct.
Have you looked at that kind of a trade-off?
We haven't looked at the predictability part, but with the network of info stations, we have looked at what portion to leave something here and what portion to leave something there. But I cannot give you. Do we have a concrete algorithm to do that right now? No.
But I'll give you an example. The combination of fleet computing. Suppose you have the integration of GIS information. So let's say you're on Miguel Data, and you tell your system, well, to pick the best way to get to center. So it will know which exit you're going to get off in the return point. Well, that's the same system could make reservations on the interfaces along the way to the better process for you, because you have better likely to tolerate.
And get your data there as well.
Correct.
Sure.
Okay. To add to Salama's comment, actually I think that testing it on an empty network is a pointless proposition. You can't make it work on a really loaded network, it's not going to work at all. In my view, they are doing the right thing to work with the next world. Internet is a collection of autonomous domains, and will be for a foreseeable future.
No, I think what Saul was saying was, suppose I report that I can route 1,000 messages. This is my performance router. What he was saying was how reliable is that measurement when you have other packets which are not necessarily geographically based is also flooding the network. He wants to know how you can. I mean, it's always the case, right? If you're running the internet, you always are affected by someone else's traffic. Yeah, that's right. So for a performance perspective, yeah, we better have our own network. Yeah. Cellular phone network, we can do it, but the problem is the granularity of location is equal to the cell size. If you want a differentiation based on slightly more precise than the cell, we need to have some other mechanism. Sure, cell ID is a good. Sorry. Then that's fine. If that is, as long as we get location information precisely, as long as the user can tell the network precisely his location, then all the algorithms that we have for geo routing and geo messaging should work.
In a way, what we want to say is we want to say the same utility which you have now on most computers inside data.
It will give you the time.
We would like to get location, you get location. How you get it, it's irrelevant for this kind of thing. Another GPS could be one location providing device, but you could have others. Technologically interesting question is how much of this can you do without touching the networking layer? Because that has to do with this router that you don't control and this impacts the larger scale testing deployment.
You mean to say the geo routing?
Everything that you have on the
For example, the geo routing stuff actually uses existing IP techniques to propagate the traffic. It's just that the routing decisions are not based on what IP would have based. It's just that we are still using IP as a transport mechanism. So that way we have not invented anything new here. It's only the ability to decipher as to where these packets would go, but still it's based on IP transport. Am I correct, Julio? Yeah.
But the flip of the product is not active. Thanks a lot of fun. That was the fun.
Any more, sir? Any more? All right. Oh, sorry. That's correct. So assume that this particular message is a special type. If this is special type, then you process using geo routing techniques. Otherwise, the normal IP packet, let it go through the normal IP routing. Sure. Oh, definitely. If you believe that you can have secure, active networks in the future, things will be easier. If we can put code, or if Cisco lets us put code safely into their router, we don't care. I mean, it's nothing to do with what we have to do. It just aids our implementation. Remember, active networks. Sorry. All right. Thank you, sir.